So last page of this section. So we're having 4.6 mixture problems on page 53 of your workbook. After this one, I have a little supplemental one that I call 4.7 that I'll add in a separate assignment. So we are going to look at when we mix two different categories together and we create a new category. For example, we can mix cashews with almonds to create a mix of nuts, or we can mix alcohol with water and create a new solution, etc. We will use a common formula to model the word problems. I'm going to call it ACT. Again, your author uses the word amount. I like thinking of it as quantity. So we might want to be consistent with that and do quantity times the cost or the concentration, like the percentage of something. So it's very similar to the money, but it could. Okay, so we're going to look at this example 4.22. You need a 55% alcohol solution. On hand, you have 80 milliliters of a 15% alcohol mixture. You also have 65% alcohol mixture. How much of the 65% mixture will you need to add to obtain the desired solution? So what we're going for is this 55%. And we have to see what the total milliliters of that is going to be. So we're taking 80 milliliters of the 15%. So that's like in this, beaker. It's my little drawing there. It's 15% and it's 80 milliliters. Okay, and together that will have a total of 0.15 times 80 milliliters. So I also have on the other side here a beaker or a spout thing full of 65% to add in with that, but I don't know how many milliliters, so I'm going to call that X. And then all together, I'm going to pour that stuff, the purple one in here and the pink one in here, and together we'll get this, make that red, 55%. And how many milliliters would that be? Well, it would be what we have here, the 80 plus my X there. So that's my total. So I have my first beaker of solution that I'm pouring in there, plus my second one would be the 0.65 times X. I don't know what that milliliters is, but I'm just going to call it X. And then equals my 0.55. This is my total in the big container, 80 plus X. So now I just need to do the math. I am going to make sure we clearly write here, let X equal number of milliliters of 65% solution, and 80 plus X is total amount of solution. Okay, so a lot of times there's different twists on these. Again, sometimes you're subtracting off, sometimes it's, just different things. You have to piece it together. But the math should be coming strongly for you now. So I'm going to have you pause and just work that out as your own classwork, and I'll write the steps just so you can match them up. So here I have 12 plus 0.65x equals 44 plus 0.55x after I distribute. And then I'm going to subtract 44 from both sides. I get a negative, but don't worry about that for now because you'll get a negative on the other side when you subtract the 0.65x. And then once you do the division in the end, you get a positive number. So I get x equals 320 and that is in milliliters. So then we want to go ahead and write our sentence. I will need to add 320 milliliters to obtain this desired solution with the right concentration. So I did a little bit of a check here because that seemed like, oh, that's such a big number. But if you think about it, my 15%, that's a pretty low percentage, and I'm not adding very much in. So I'm going to need to add quite a bit more of the higher concentration stuff to bring that level up. So I just plugged my 320 in to see if it made sense to the problem and if my uh, sides balanced, and they did. So it's good to go there. Okay, last problem for this set. We have example 4.23. A store owner wants to develop a new snack mix by mixing chocolate and trail mix. How many pounds of chocolate costing $20.90 per pound should be mixed with 15 pounds of trail mix costing $4.50 per pound to create a mixture worth $11.79 per pound? So that's what we want our value to be. And we are looking at how many pounds of the $20.90 one. So we're going to let X equal number of pounds, the pricier one, higher cost, okay? Chocolate. And then we're going to mix that with the 15 pounds of trail mix. Know that we have 15 pounds trail mix, the cheaper. We need one more relationship here because our final mixture is going to be what we put in for chocolate plus our 15 pounds of the trail mix will equal our total pounds of new mix. So that's important. Make sure you add that in because otherwise it's not going to work out because we have to adjust that total. It's not just the 15 pounds, that's only the trail mix. We have to add the X on. So that's part A. Part B, now I'm going to set up my equations. I would have my value of the expensive one times X, which is my quantity, plus my value of the cheaper one times my quantity, which is 15, equals the value of my new mix, 1179, times my pounds, which is X plus 15, because I set that out. Now I just need to distribute, got to do my calculations here, combine like terms, solve. So go ahead and pause and do that. 20.9 X plus 67.5 equals 11.79 X plus 15 times the 11.79 comes out to be 176.85. Then we're going to go ahead and I'm going to subtract 1179 X from both sides. So that's 9.11 X. Then I'm also going to subtract this 6750 there. So 176.85 minus 67.5. And we're streamlining our steps here now, just like you could do too. 109.35. And then divide both sides by 9.11. And we get 12 0.003, so about 12 pounds. So the question asks just how many pounds of chocolate would I need to add. So some rounding happened through here. So I'm going to say add 12 pounds of chocolate to get the new mix. And then you could check also and see, like, does that make sense to the problem? That would be 12 plus 15, so I would have a total thing of 27 pounds times 11.79. So that would be, I'm just going to jot down some numbers here. So that would be 318.33 total. And then if I looked at my 15 times 450 was 67.50. And then I have the 20.9 times the 12. That should be, whoops, I hit 120.9. 20.9 times 12 is 250.80. So that's my chocolate is right here. That's how much altogether value of the chocolate. Here's the trail mix. And then when I, add those together, those should add up to my cost, overall total cost for the new mix. So that looks good. So I am going to get this video posted for you and have a great day.